Alright, Algebra 2 crew, it's time to take a trip back to ninth grade. We're going to deal with Module 1, Chapter 2, Lesson 1, and we're going to go take care of basic factoring back from 2 years ago and review it all again. As we do this, it's going to basically take a look at all your steps in factoring. You should remember the first thing we always do is the GCF, pulling out the greatest common factor. Followed by, it's a binomial. We do DOPS, difference of two perfect squares. Your typical trinomial you guys like, which is to factor into two binomials, remember, x and all that good stuff. And then eventually we're going to get into these other methods down the road here, borrow and payback, and AC method, completing the square, grouping, quadratic formula. So everything from the past. Have a ball here in this chapter, and then we're going to take it to another level. So hold on to your seats. Alright, with the GCF method, we're looking for the greatest common factor. Remember, you've got your calculator, and you can always hit that in math num 9, and then put in 8, 12, and it will tell you the GCF. At the same time, you guys should be pretty good at this, okay? What number here goes into both 8 and 12? What's the biggest number that goes into both? And of course, in that case, it's going to be a 4. So your GCF, you pull out the 4. They also share, if you take a look here, they both have at least one x. The first one has 2. The second one has 1, so we're going to pull out 1x. And then what's left? If I take a 4 out of 8, I'm left with 2. 4 times 2 is 8. I take 1x out, I'm left with 1. A plus sign then, and I take 4 out of 12, I'm left with 3, and the x is already gone, and there's your factor. So pull the 4x out. You can always turn around and check it by distributing. 4x times 2x gives me this. 4x times the 3 gives me this, okay? So take a look at number 2 here as an example. Same situation here. On all of them, this time though, you got to make sure it's in all 3. So what do they all share? Well, they definitely all share a 5. Do they all have an A? Yes. 2 of them have 1A. And one of them has 2. You can only take the smaller of it. So they all have at least 1A. So I will pull out 1A. And then they all have at least a B as well. So I will pull out a B. Then when I fact what's left, you take the 5 out. Okay, so you got to take the 5 out of here, the 5 out of there, the 5 out of there, the A out of each, the B out of each. Okay. So I take the 5, the A, and the B out of the first one. All I'm left with is a B. Take 5 out of the second one. I'm left with a minus 3, and the A and the B are gone. And then the last one, 5 goes into 20 4 times, and I have an A left. So there's my answer. Remember, that's a B right there, not a 6. So it's 5AB times that. And once again, if you want to check, distribute this whole thing times it, you should get each piece back, okay? If you go and do the distributing. All right, so that's reviewing the GCF method. You're going to practice more in class tomorrow. Now we're going to move on to the next method you learned. Alright, on this page here, we're going to go to number 8. We're going to start doing the DOPS method right up here. Difference of perfect squares. Well, we've already covered this in class this year and talked about a bunch of them, especially with our Pythagorean identity. So we already know that a squared minus 49, that's a perfect square, that's a perfect square, and I got a subtraction. So real easy. A squared is A and A. 49 is 7 times 7, and one of them has to be plus, one's minus, and it doesn't matter the order. I just happen to like plus and then minus. We take a look at the next one here. 25 is a perfect square. K squared is a perfect square. We have our minus sign, which is critical. Cannot be an addition. We have 100 as a perfect square, and k to the 6, believe it or not, is a perfect square. Any exponent that is even is a perfect square, because remember, k squared is k and k. You cut it in half, 1 and 1. So that's what we're going to do with this here, too, on the 6. So, talking about it, I know I got the difference two perfect squares, so I got 5, and I got a 5. We know k squared is k and k. So 5k and 5k give me the 25k squared. One's plus, one's minus. Then we've got a 10 and a 10. And then k to the 6, just cut it in half. So it's going to be k to the third. K to the third. I should have left myself some more room, but it's good to go. So, difference two perfect squares, still the same type of situation. That's just the only thing you got to remember is K to the 6th would be 3 and 3. If it was something to the 10th, it would be 5 and 5, okay? Moving on to the last type we need to review from 9th grade. So, if you factored and you can't pull out a common factor, like in this case right here, no common term between all these other than the number 1 goes into all of them. They don't all have x's, they don't have a number. It's definitely not a binomial, so it's not the difference of two perfect squares. So we're going to factor into this, and we call that reverse FOIL for some of you. We haven't been using the term FOIL too much anymore. Getting away from it, but reverse distribution, whatever way you want to call it. So, if I have a trinomial, we try to factor it into two binomials. So, how do I get x squared? I get x and x, okay? And then there were all kinds of rules you need to go back and remember. A lot of us told you, hey, what are your factors of this last term right here, 7, and you wrote them all down. Well, there is only one way, 1 and 7, so this one's easy. The only way to do it is 1 and 7, okay? Then you had this thing called the boss right here. If it's a plus, you need the two numbers here. So if you have a whole list of a bunch of factors, 7 is not, it only has 1, so obviously you're stuck with that. But if it is a list, you want the pair that adds up to this middle number 8. Well, obviously 1 plus 7 does add up to 8, so I got the right pair. This adding sign also tells me what's going on with the signs for the two. If it's first of all, no matter what we told you back in 9th grade, bring this sign down. So I put the plus here first, okay? If this is a plus sign, they are both going to get that middle sign, okay? So in this case, they're both going to get a plus. If that's a minus, I need one of each. So if that's a plus, that would be a minus. If that turned out to be a minus, that would be a plus, okay? But the bottom line here is that is a plus, so they are both going to be the middle sign, which in this case is both plus. And of course, if you want to check it, you can use tabular. Multiply the 2 and make sure you get the same thing back, okay? Down to 25 is another one here. All right, so once again, no GCF around here at all. I mean, these two can be divided by 2, but this one doesn't, so there's no GCF. So once again, 2 sets of parentheses. X squared's easy, x and x. Factors of 22, 1 and 22, and 2 and 11. That's it. So it's another easy one. There's only 2 choices. Well, which pair, look at the boss, subtracts this time to the 8? All right, so we ran into a problem here. If this middle number here was not an 8 and it was a 9, we would pick this pair because 11 minus 2 is 9, but it's an 8. Neither pair, though, unfortunately, this one, 22 minus 1 is 21, and 11 minus 2 is the 9. Neither one works. So guess what? This one here we would say is not factorable. Okay? It's not an easy fix. We tackled it another way later on in 9th grade, and we will get to that in a couple of days. Just a review again, but not at this point. This one we're going to leave as not factorable. But just to sum it up again, you get a trinomial, normally split into 2 binomials, and that boss, this boss guy right here, is a big key factor in that, okay? So, we're going to talk about more in class. You're going to get a lot of practice in class, because I'm sure your skills are a little rusty still, as we've seen for some of you, and we'll go from there. But we have to be able to factor, because a good chunk of this year is factoring. So we got to know how to factor, or we're going to be lost in the sauce. Have a good one. I'll see you in class.